Good morning, ladies and gentlemen. I welcome our friends who have joined us online. We are aware that teaming of manned and unmanned autonomous vehicles enhances the mission effectiveness by providing greater situational awareness and decision-making capabilities. So, effectively, MUMT, in short, has revolutionized the mission autonomy, incorporating unmanned autonomous system into the mission planning expand the ranges of the tactical sphere, while it also mitigates the risk to human and technological assets under hostile environments. Amalgaming human intelligence with artificial intelligence in planning and decision-making processes, it helps to ensure accuracy, operational flexibility, and continuity of machine learning. In the series of Thursday lecture at CENJOWS, on behalf of Wg CdR, I welcome you all. Today we have with us Wing Commander Vishal, who shall be talking about and will introduce us to the technological and operational nuances of the subject. With his vast experience and with his first-hand experience as a pilot, we are fortunate to listen to his insightful discourses on the subject. May I request Dr. Lupi to read out the facts.
Thank you, sir. Wing Commander Vishal Jain was commissioned in the helicopter stream of Indian Air Force on 21st of June 2003. He has over 3,300 hours of flying experience on Cheetah, and all variants of the Mi-17 helicopter and has flown extensively in the northern sector. He is a qualified flying instructor and an instrument rating instructor and examiner. He has been the flight commander of 2 premier twin-engine helicopter units and has commanded a frontline helicopter unit. He is an alumnus of National Defense Academy and graduate of the Defense Services Staff College, Wellington. He has been commanded twice by the Chief of the Air Staff during his career. He is presently engaged as a senior fellow at CENJOWS. Thank you, sir.
Good morning, ladies and gentlemen, and thank you, Dr. Lupi, for the introduction. So we see that today the world is witnessing exponential technological advancements that are taking place, and those advancements in the military domain are rapidly changing the landscape of battlefield and are causing a paradigm shift in the nature of war and the manner in which the war is being fought. The arrival of uncrewed platforms on the scene has altered the basic architecture of the aerial warfare. But we have seen that as this technology has proliferated and become more accessible and affordable, it has transformed the operational doctrines and concepts for everyone. And we can see its impact in the conflicts in the recent past and more importantly in the ongoing ones. However, this was not radical enough. The concept of teaming these uncrewed or unmanned platforms with crewed and manned platforms came into being. And this is going to cause a revolutionary transformation in the conduct of air operations. So today I'm going to be talking about the concept of man-unmanned teaming, or MUMT, as it is more commonly referred to by the practitioners of aerial warfare. So the concept of MUMT involves a collaboration between manned platforms like aircraft, naval vessel, ground vehicles, and unmanned platforms like aerial drones, unmanned surface and ground underwater vessels, unmanned and autonomous ground vehicles, robotic surface devices, and autonomous munitions. The purpose for which these platforms could be used could range from reconnaissance to battle damage assessment, hosting the sensors for gathering information on the target, or for the unmanned platforms carrying out offensive actions by themselves. The aim here is to leverage the strengths of manned and unmanned systems to improve the efficiency and effectiveness of the operation, enhance situational awareness, survivability, lethality, have deeper sense and weapon penetration, and by all this, enhance the chances of mission success. Now, as a concept, MUMT is not new. It has been thought of and tried in the past. So let's go a bit into the history. During the Cold War, the US developed a covert spy plane called the U-2. This aircraft was able to fly at altitudes more than 70,000 feet and was used for primarily gathering intelligence on the Soviet Union. It was thought that the aircraft cannot be detected by radars by virtue of it flying so high. And the aircraft flew intermittently between 1956 and 1960. But eventually on 1st May 1960, it was shot down by the Soviets. And with the capture of the captain of the U-2, Francis Gary Paz, and the wreckage of the U-2 itself, the American League was established, and the Soviets demanded that the US cease any more flights over the Soviet airspace. So this led to the development of the M21 D21 pair. The M21 was the manned mother plane, and the D21 was a supersonic recce drone carried on the back of M21 on a pylon. Now, this pair was able to fly at altitudes above 90,000 feet at supersonic speeds above Mach 3. The D21 was to be released by the M21 at the operating altitude by a launch control operator who was seated inside the M21. After the launch, the D21 was designed to autonomously fly to the target area, conduct the recce mission, and then fly to a predetermined point, release the ISR package, and then self-destruct in air. Several test flights were conducted, but because during the fourth test flight on 30th July 1966, a catastrophic accident occurred wherein the D21 was unable to successfully disengage from the mother aircraft. It led to a catastrophic accident and the program was discontinued. Though unsuccessful, the concept of MUMTI was demonstrated by this M21 D21 pair, which at that time was ahead of its time. Now, principally, a MUMTI system comprises of a manned mother aircraft, which is teamed with one or more unmanned aircraft or drones that could be purpose designed or could be reconfigurable as per the mission requirements. The drones would essentially be capable of autonomous operations, but would also have the ability to be tasked in air by the human in the loop who is present inside the mother aircraft. The role granted to these drones could be reconnaissance, comment, target designation, decoy, or kinetic role to take on targets on ground or in the air. Now, there could be other elements that could be integrated into the systems like autonomous robotic platforms on ground in the tactical battle area, air-launched drone swarms released from the mother aircraft or another drone, and loitering munitions launched from ground or in air to increase their range. Of course, all these elements will have to be in communication with each other to a secure and resilient communication data link capable of networking. There have been tremendous progress in the drone space that we are seeing every day. The capabilities of unmanned aerial systems are breaking new boundaries. Multitudes of tasks that were traditionally done by humans are being done by drones today with greater speed and efficiency. But the concept of MUMTI enhances its growing potential to another level, especially in the military domain. A major dilemma staring everyone today is the ethical question of granting full autonomy to armed unmanned platforms, commonly known as lethal autonomous weapon systems, and trusting AI to make decisions involving lives of human beings. Now, misidentified and misjudged strike may lead to a loss of life of an innocent or cause unacceptable level of collateral damage. With MUMTI, the presence of human in the loop provides a safeguard and an option of overcoming the ethical dilemma. The uncrewed member of the MUMTI system will be able to operate deeper inside the enemy territory in a hostile environment with its sensors gathering and relaying information that is more profound. This will enhance the situational awareness of the commanders and enable them to take better decisions in a dynamic environment. Now, with MUMTI, armed uncrewed platforms could carry out strikes on heavily protected targets deeper into the enemy territory. This without the risk of losing the operator. So this increases the risk of acceptability of the mission and enhances the lethality of the operation. The replacement of manned aircraft with unmanned platforms for conducting missions in a heavily contested environment with human vigilance changes the risk matrix drastically and improves the survivability of the fight. Also, the unmanned platforms are many times cheaper than the advanced high-tech manned aircraft, which means for the cost of one manned platform, multiple unmanned platforms can be procured. This also means reduction in cost due to attrition. The reduced exposure of the pilot to risk and its greater survivability also reduces the cost of training and the time that is required to replace a down pilot in case of conflicts, as well as an overall reduction in the autonomy of operations and number of pilots needed in a force, maybe. So this means that conducting operations using MUMTI vis-a-vis manned aircraft would turn out to be more economical. The ability to pair unmanned platforms with manned platforms enables enhanced situational awareness and minimizes the risk exposure to human pilots, while allowing optimal utilization of the full range of platforms with diverse capabilities in an integrated manner, and allows sharing of this data and picture with other friendly assets in all domains. This ability of MUMT makes it a force multiplier, increasing the efficiency, lethality, and speed of operation. It leverages the strength of crewed and uncrewed systems, complementing them to accomplish more with lesser resources. Now, MUMT is a concept that amalgamates existing and under development technologies, for example, the latest generation fighter aircraft, advanced helicopters, autonomous drones, loitering munitions, advanced sensors, and many more things. However, there are certain critical technologies that are essential for amalgamation of all these things to take place and bring the concept to fruition. One of the most important requirements would be a secure wideband communication. Now, this would be required to integrate all the components of the multi-systems and enable sharing of large volumes of data between them, as well as with other airborne and ground systems and command control centers. This will need to be resilient enough to remain operational amidst the intensely contested EW environment. And networkability and interoperability are two other key requirements. The communication system will also be need to be capable of line of sight, non-line of sight, and satellite communication to enable data sharing between the multi components that are operating in close proximity of each other or diversely. Now, these unmanned platforms will need to be automated so that they can take off, land, plan the mission profile as per the allotted mission, be able to take evasive action, make decisions in case of threats, operate in synchronization with the manned and other unmanned components of the multi-system. Therefore, the incorporation of AI and ML in these platforms would be the basic necessity for such automation to happen. There will be a great deal of data that would be generated by the numerous sensors that would be present in the multi-members, especially those with ISR role. However, all this data need not be present to the pilot of the mothership, as that could lead to information and cognitive overload and possible decision paralysis. So, and transmission of this data to ground and back for processing would lead to loss of critical time. Therefore, edge processing on the unmanned platforms would enable faster sorting of data as per the mission requirement and enable mission specific data to be presented to the pilot for quicker and real-time decision making. Now, whether strike or ISR, automatic target recognition is an essential capability in unmanned platforms for accurate and effective execution. Though automated, the human in the loop will still be required to exercise control over the unmanned platforms as a concept in MUMT. So, use of virtual reality, augmented reality, mixed reality in the simulators, along with the data from actual missions, will enable more realistic training for the crew. And the lessons derived could also be used to improve the performance of the system, unmanned components of the system itself. There has been a growing comprehension of the importance of the MUMT and its advantages in around the world, and various nations are investing in more and more research and development of this technology for its incorporation, integration. They're also developing doctrines and for its employment. So let's have a look on some of the systems that are being pursued worldwide. The Apache attack helicopter of the US has already been fielded with MUMT capability. There are two variants, AH-64D Longbow and AH-64D Guardian. The MUMT version of Longbow is a MUMT LOI2 capable. That is, it receives sensor video from sensors of the unmanned aerial systems directly over data link. The MUMT equipped Apache Longbow can retransmit this data along with its own sensor data and metadata to other MUMT equipped Longbow helicopters and to ground forces with a remote video terminal. The second system is the MUMT version of the Guardian helicopter that is equipped with the L3 Harris Manned-Unmanned Teaming communication system. This has a LOI capability of 3 and 4. With this, the Apache Guardians can have a direct control over the sensors on board multiple RQ-7B Shadow V2 and MQ-1C vehicle unmanned aerial systems, as well as they can control the flight of these unmanned systems. The Guardian can also control the weapons carried by the Grey Eagle. The ISR data can also be shared with other suitably equipped Apache helicopters, as well as relate to command control centers and to troops and ships on surface. Skyborg is the US Air Force's autonomous aircraft teaming architecture that aims to integrate manned and unmanned platforms to realize the MUMT concept. It has an open architecture that enables it to be integrated onto a variety of aircraft platforms. The Skyborg autonomy core system has already been integrated onto the Kratos XQ-58 Valkyrie and the General Atomics MQ-20 Avenger unmanned platforms, so they can be paired with the F-22 F-35 fighters. The plan is also to integrate low-cost attritable aircraft technology using Skyborg via the next generation air dominance fighter program. So there have been some rumors that the NJD program has been paused due to escalating costs and budget constraints in the new administration. Then is the future combat air system of the Europe, which is a joint venture by France, Germany, and Spain. There are multiple companies involved like Dassault Aviation, Airbus, Indra, EUMET, and the industry partners. This system, the FCS, comprises three main components: the new generation fighter, which is a sixth generation fighter, manned aircraft. The unmanned components are called the remote carriers, and the network combat cloud that connects the manned and unmanned components and allows integration of existing system due to its open system architecture. Together, these three form the next generation weapon system. The remote carriers will support the manned aircraft in enhancing its situational awareness by taking on the role of ISR, as well as support it in EW and kinetic modes. Then is the Loyal Wingman, Christian, the MQ-28 Ghostbat. This is an unmanned collaborative combat aircraft, which is being developed by Boeing, and it promises fight-like performance. This will undertake missions like ISR, tactical early warning, and more. It will work smartly in collaboration with the existing military aircraft and act as a force multiplier. The Ghostbat is to be a part of the Royal Australian Air Force's Manned program, and it could also be part of US and UK's Manned projects. The Turkish aerospace industry, along with the BAE Systems as subcontractor, has been developing its own fifth generation stealth air security fighter Khan, which we are all aware, and this particular aircraft made its maiden flight on 21st February 24. To be integrated with this, it has also developed its own Manned concept with the OKU, or the Autonomous Wingman concept. The OKU is being developed as a loyal wingman to Khan ASF, and TAI has also commenced studies for the development of the concept with Khan and Anka 3 UAV. Okay. Russia has been a relatively late entrant into the race of developing Manned systems. However, it has tested its UCAV, the S-70 Okhotnik B Hunter with its fifth generation fighter Su-57 in September 2019. The UCAV was subsequently also tested with unguided bombs for ground attack and with air-to-air missiles and precision guided munitions. It is likely that the Su-57 will be paired with up to 4 Okhotnik B UCAVs, and it may also be paired with the Su-34 fighter. South Korea has also entered the foray. The Korea aerospace industry has been working to create a combination of its manned KF-21 F-50 fighters with unmanned fighters or loyal wingmen, and the small-sized UAVs or air-launched effects to realize its concept of Manned. For this, they plan to use a twin-seater version of the KF-21 fighter. The plan is to design wingmen capable of undertaking ISR, EW, decoy, and strike roles. KI calls its ALEs as adaptable aerial platforms. The plan is to pair 4 loyal wingmen to 1 KF-21 manned fighter and 3 to 4 AAPs with each loyal wingman. The roles for which AAPs are being developed include decoying, jamming, ISR, and strike. Coming to China, the ATFTC has been working on a low detectable twin-engine small autonomous combat aircraft called the Fayong FH-97. This is being developed as a loyal wingman to the Chinese stealth fighter J-20. Apparently, it is being developed in 2 specialized versions: the air-to-air mission-oriented FH-97A and the air-to-ground mission-oriented FH-97. The UCAV can carry 8 air-to-air missiles or loitering munitions and can undertake long-range ISR, EW, and strike missions. Now, the Manned program of India was conceptualized in 2017 and is known as the Combat Air Aiming System. It is being developed by the HAL for the Indian Air Force and is planned to be jointly produced by the HAL, the DRDO, the NAL, and the New Space Research and Technologies. CATS is an umbrella term that comprises a system of manned fighter paired with an unmanned wingman and other unmanned assets that will be able to operate together in a contested environment and carry out strikes deep inside the enemy territory with minimal exposure of the human pilot to risk. The CATS is based around the manned mothership called the CATS MAX, which stands for Mothership for Air Teaming Exploitation. This will be an indigenous LC Tejas or Jaguar Max. The main components of CATS are the CATS Warrior, CATS Hunter, CATS Alpha or Air Launched Flexible Assets, as I call it, and CATS Infinity. CATS Warrior is the unmanned stealth autonomous wingman of CATS Max. It will be able to team up with the existing platforms like the Su-30 and the upgraded version of Jaguar Max. 2 to 4 warriors will be paired with one mothership, and that will be able to control the warrior from as far as 150 kilometers, and the warrior will have a radius of action of about 350 kilometers. Each warrior will be able to carry 24 Alpha swarm of smart loitering munitions and can also carry 2 new air generation air-to-air missiles or 2 DRDO smart anti-airfield weapons internally. It will carry its own sensors and will improve situational awareness of the CATS MAX by relaying this data to the mothership. This short clip depicts how CATS warriors intend to be exploited. Combat air teaming system. शत्रु का वॉरियर्स अपने टीम के सुरक्षा कवच में लौटेंगे। टीम मेंबर्स हैं पेसर वॉरियर, ईडब्ल्यू वॉरियर, डीकॉय वॉरियर और टीम का प्रमुख स्ट्राइक. Now the CATS Hunter is being designed as a low observable standoff recoverable air launched cruise missile that will be powered by a turbojet engine and can be reused. It could be launched from CATS MAX, Su-30, Mirage or Jaguar aircraft. It will have an internal bay for carriage of a weapon of up to 250 kg unitary warhead or cluster munition as per the mission requirement. It will have a range of 300 kilometers and will be recoverable by parachute. It will feature autonomous guidance using satellite-based navigation and terrain control matching, and a seeker for automatic target recognition. CATS Alpha is being designed as a container that can be carried by the CATS Warrior or a manned fighter. It will carry the Alpha form of loitering munitions, which will be armed with a warhead of 5 to 8 kgs each. The container will be able to glide for 100 kilometers after releasing the Alpha swarm. The Alpha swarm will then fly under its own propulsion to targets like aircraft on ground, SAM systems, and other targets on the surface. The networked Alpha swarm drones will be capable of automatic target detection, allocation, acquisition, and targeting with the aid of the onboard seeker and AI-based algorithms. Alpha S could also be used for ISR missions or as radio relay to extend the control range of the CATS Warrior from the mothership. CATS Infinity is being developed as a high-altitude pseudo-satellite unmanned platform. It will be powered by solar energy and will be able to stay at an altitude of 70,000 feet for a duration of about 3 months. With the aid of the onboard sensors, the Infinity will be able to provide real-time ISR inputs for conducting missions like deep penetration strike, battle damage assessment, and help build and maintain situational awareness of the area of operation. It may also be able to provide networking and control of various elements of the CAT system. All these components, of course, will need to be networked through a data link. Also, to realize the Indian Mounty concept, an advanced AI-based combat algorithm is being developed under a program called the Air Combat Intelligence Development. With regards to the latest updates, it was reported that in January 2025, that is this year, DHL successfully conducted the engine ground run of a full-scale demonstrator for the CATS Warrior. This engine is an indigenous, fully indigenous engine. HAL also showcased the first prototype of the Warrior that has been manufactured for ground testing during the Aero India show. And it is of mostly composite construction. It uses radar absorbent structures and radar absorbent material for low observability and has a twin engine configuration. The plan is to integrate the Warrior with Tejas Mark II and subsequently with the Ampha. In the case of CATS Hunter, test flights are expected to commence later this year. Now, the concept of MUMTI is a very promising concept, but it comes with its own set of challenges in realizing the concept itself and the employment that need to be addressed. The integration of system and sensors in MUMTI will culminate into a dataset that will be too large for the human mind to process, even after it has been sifted and sorted. So issues such as increased workload, task saturation, visual overload, they have been highlighted during the test flights of MUMTI systems. The idea of MUMTI is to increase the efficiency and lethality of the mission by integration and automation. Therefore, intelligent processing of the data to present relevant information to the pilot, to the human operator, is a key focus area. Aeronautical aspects of distraction, motion sickness, and reduced situational awareness, increased risk of spatial disorientation due to conflicting sensory inputs between the aerial platform motion cues and visual inputs of unmanned aircraft orientation. All these are significant issues which are facing the MUMTI operators. The backbone of a MUMTI system is its communication link. Without it, it is impossible for the concept to become a reality. The communication link needs to be wideband so that it can support speedy flow of large volumes of data. It needs to be robust and jam resistant so that it can remain operational in an intense ECM environment, and it also needs to be cyber attack resilient. For successful integration of all components of a MUMTI system, they need to be able to seamlessly communicate with each other. This means they all need to be developed on a common and standardized communication protocols to ensure interoperability of the systems. Standardization is another major challenge in integrating the MUMTI components. Various parts of MUMTI systems will be developed by different agencies and manufactured by various manufacturers. Also, different services may demand products with specific requirements of their own. However, from point forward, all products need to be manufactured as per standardized norms so that they are all compatible and integrable with each other as and when needed. This will ensure interoperability and versatility of these systems. A great deal of autonomy is required to be built into these unmanned platforms so that they are able to take off, recover on their own, navigate to the target area or a specific target, plan a navigation route depending on the terrain, atmospheric and electronic environment, rendezvous with other elements of the system, and other collaborative functions. This would require an intrinsic complex AI-based programming to be developed and embedded into these platforms. It will also have to look into the issue of safe operation of MUMTI elements in close proximity of each other and of the manned mother aircraft. With full or partial autonomy of the individual platforms as well as of the system, complex decisions will have to be made for functions such as evading threats in a highly contested environment, detecting and identifying targets, allocating targets to the kinetic components of the system, deciding weapon density required on the target, and so on and so forth. So this calls for a very advanced AI-based combat algorithm to make these split-second decisions autonomously and for intelligent task distribution between the manned and unmanned systems, so as not to overload the human operator. The integration of technologies in MUMTI allows its elements to undertake roles and tasks that were earlier the domain of human beings. And this will be done with better precision in a heavily contested battle space with more risk absorbing ability from extended ranges with better safety for the human operator. So let's see some applications of MUMTI. Integrated offensive combat operations can be conducted with manned and unmanned air and ground systems working in tandem to locate, track, and hit targets with speed, precision, lethality, and reduce exposure of the human operators to risk. The unmanned kinetic elements of a MUMTI system can be used to carry out coordinated strikes on enemy air assets on ground, offensive ground or maritime forces elements, command control centers, airfields, logistics nodes, and air interdiction targets. The unmanned components of the system can be used to carry out ISR missions with extended range and endurance deeper into the enemy territory against heavily defended targets. This will produce real-time intelligence, enhance situational awareness, execute speedy battle damage assessment, and allow making time-critical decisions. Multiple wingmen equipped with ECM equipment like jammers can be employed to fly as escorts to manned strike aircraft. This will counter multiple threats from airborne platforms and surface to air guided weapons. Unmanned components can also be tasked to fly as decoys and take fire in case of a threat to mothership and create distraction. Unmanned multi elements can be made to fly ahead of the main strike package, undertake kinetic strikes or EW operations against ground-based AD elements, and soften the battle space for further operations. Multi systems can be utilized in counterterrorism and counterinsurgency scenarios. This can be used to provide persistent surveillance as well as precision targeting in areas that have not been sanitized. Use of MUMTI can be made in air logistics operations where ammunition and material support needs to be supplied to troops in hostile environment, where there is too much risk for manned aircraft operations. Presence of human in the loop will serve to take tactical decisions to deliver accurately and safely. Air logistic operations to places restricted for landing of manned aircraft can also be benefited from this use of MUMTI with the use of swarm of smaller logistic drones. Multiple unmanned platforms together can be utilized to search for casualties or survivors over large areas. This will provide real-time information. This will also make the effort more coordinated, reduce the time to respond, and rescue the survivors, increasing their chances of survival. Employment of system over hazardous and challenging terrain like mountains, expansive water bodies, or oceans will pay great dividends. Civil applications where MUMTI can be extended could be disaster management, firefighting, policing, radiation chemical poisoning incident management. This will reduce the exposure of human beings to risk and ensure continuous and all-weather conduct of operations. Man-unmanned teaming is at a crucial stage in its development. MUMTI offers great potential to overcome the shortcomings of manned platforms while maintaining human control, but with greater awareness and less risk exposure. However, the complex challenges in the path to realize the concept, like technological advancements that are needed to realize the concept, the human factors involved, and making the system more and more resilient need to be addressed. More R&D needs to go into adopting the loyal wingman for air-to-air role, graduating its capability to near manned aircraft, while keeping the cost low, as that is the significant advantage of the system. More needs to be done in exploring the ways that MUMTI can be exploited and in working out a concept of operations for it. In India, more focus needs to be given on hastening the development of CATS and becoming as much self-reliant as possible in MUMTI-related technologies, two significant ones being the communication data link and combat algorithm. Efforts should be made to adapt the existing platforms to max capabilities by reconfiguring the cockpits with advanced avionics and other systems required. More and more private industry participation must be sought to develop the required solutions. Early realization of the concept could be able to partially address the fighter spawn deficiency in the Air Force. Unmanned ground vehicles and unmanned surface vehicles for integration with CATS and the Air Force, Naval and Army systems must be developed so that it eventually leads to an integrated system of systems in the true sense, which will lead to ultimate synergy and coordination in carrying out integrated operations. MUMTI should also be developed for rotary wing platforms on the lines of Apache Longbow Guardian program of the US. And this should involve the integration of armed helicopters that are available in much large numbers. MUMTI technology offers prospects to enable the forces to achieve superiority and be more agile, adaptive, and effective in a security environment that grows more challenging and complex by the day. MUMTI is going to become an indispensable part of every modern future-ready force and is poised to govern the manner in which they are going to tackle future conflicts and fight future wars. It is in fact going to revolutionize the concept, the conduct of military operations, and redefine the nature of aerial warfare. I'll end my presentation with a small clip that visualizes how a MUMTI system would manifest itself in the future battle space.